All right, so we're going to look at vertical angles and linear pairs today. Oops. Here we go. All right, so the first thing we want to talk about is the linear pair conjecture. Now, your book, remember how I told you a while ago a conjecture, once you prove that true, is called a theorem? Your book never gets away from the word conjecture. So I don't care if you call it a theorem, I don't care if you call it a conjecture. Your book always refers to it as a conjecture. So the linear pair conjecture says that if two angles form a linear pair, then the measure of the angles add up to be 180 degrees. Not surprising to you, right? We've done this. We've talked about this. So take a second here. I want you to solve for x. Okay, so what did you get for x? 124 degrees. Questions on how to get that? All right. The next conjecture we're going to talk about is the vertical angle conjecture. It says if two angles are vertical angles, then they are congruent. Again, should not be a surprise, as I told you this in chapter 1, right? Okay, so take a minute here to solve for x, y, and z. All right, so what other value has to be 125? Y does. Good, and then I can solve for x or z by using linear pairs, right? So what's the value of both x and z? 55. Questions on how to get either one of those or any of those measurements? Yes.
180 minus 125.
Yep. Is everybody, I'm just asking if everybody's okay with that. Yep. Okay. All right. So now what I want to do though is I told you just to trust me that that's the way it is. Today I want to look at why it is the way it is. All right. So did everybody get a piece of patty paper from the table here? This is patty paper. It is actually. So patty paper usually sits between frozen hamburger patties, so you can get them apart. That's what patty paper is. All right, so patty paper, we like to use it sometimes in geometry because you can draw on it and you can see through the paper easily, so we can compare things. All right. So what I want you to do, take your patty paper. So let's pretend this is my patty paper. I want you to take your ruler and I want you to draw two intersecting lines. Okay? It doesn't have to go from corner to corner or anything. It doesn't matter at all. Just make it, don't make it teeny tiny because we're going to do stuff with it. It's teeny tiny here after this. After you have that done, I want you to number your angles 1, 2, 3, and 4 so that angles 1 and 3 are vertical and 2 and 4 are vertical. So kind of like in a circle. Everybody good there? All right, so what I would like you to do now, we want to compare vertical angles 1 and 3. Okay, we're going to compare vertical angles 1 and 3. We're going to fold our patty paper so that it folds through the vertex, but I want to lay the legs of angle 1 on top of the legs of angle 3. So you might have to hold it up towards the window or towards the light a little bit, but we want to fold it through the vertex, and I want to try to line up the legs of angle 1 on top of the legs of angle 3.
Wait, like
So it should kind of look like a V.
This is so good. Wow. It's just good. My husband loves it. I just feel like the things at a weird angle. So I love
All right. So did the legs line up perfectly? No? I hear no.
it's close enough.
Close enough. All right, now verifying for angles 2 and 4. So open it back up. Open it back up and compare for angles 2 and 4. Did it work again? Kind of. All right, so this is kind of a visual confirmation that vertical angles are congruent, right? It wasn't a fluke, or I didn't lie to you and make things up. Okay, so we confirmed in 22 cases in this room that vertical angles are congruent. For those 22 sets of vertical angles that we have drawn out, count for all the vertical angles in the entire world.
No.
No. So we have 22 confirmations for specific scenarios, but what we need to do is prove it for all vertical angles from here on out. Okay? That's what we're going to do next. We're going to write a formal geometric proof to show that all vertical angles are congruent. Okay? When we write proofs, since this is our first proof, there's information that's typically given to you, so your starting point. There's a proof statement, meaning where you want to end up. There's typically a figure. Those three things are typically given to you to start with. And what your job is then to do is make statements and reasons to back it up. So do you remember the other day when we were solving that equation and the first thing we had to do was a distributive property? So we distributed and we said we could do that because of the distributive property. And then I think we combined like terms and we said we could do that because it was just combining like terms, right? Those were statements and reasons. That was an algebraic proof. We're going to do a geometric proof. All right, so we're going to prove that if two angles are vertical angles, then they are congruent. The if part of that, it's an if-then statement, right? The if part of that is where we're starting. That's the given. Okay, so I'm going to write this all out for us. And then we're also going to decide what exactly we're going to prove. We're going to start with our figure. That's the worst line I think I've ever drawn. All right, we're going to start with a figure. I'm going to label those three angles. So I have this figure. I labeled angles 1, 2, and 3. I'm not going to label the fourth angle because we're not going to need it. And I wouldn't expect you to know that you needed to not label that angle at this point. Okay, so this is something, proofs are something you get better at as you practice, and experience helps you figure out what you need and what you don't need. You are nowhere near close to being ready for that. So don't panic if you wouldn't know what to draw or how to draw it. Okay, at this point, that's my job to provide it for you. All right, so our given is the fact that we have vertical angles. So which angles up here are vertical angles? 1 and 3. So my given are vertical angles 1 and 3. I don't leave myself much space. My given is the fact that I have vertical angles. Angles 1 and 3 are vertical angles. I want to prove that those angles are congruent. So So I'm going to prove that angle 1 is congruent to angle 3. So we're going to list a bunch of statements and reasons. The statements go on the left. The reasons go on the right. So we write proofs that are called T-chart proofs because they're in the shape of a T. You could also write proofs in paragraph form where you write out like full sentences. But as a mathematician, I don't want to have to write a sentence if I don't have to. Right? That's why I like to abbreviate everything. That's why I like numbers. It's quick and easy. We could also make a proof or draw a proof in what's called a flowchart proof, which we'll do later on. Is more of a pictorial version of a proof. Okay, so this is kind of like a happy medium. So we're going to write statements and reasons to show how we started with the fact that we have vertical angles and prove that they're actually congruent. Our reasons have to be mathematically proven, or have to be like mathematical statements that you already know about. So for instance, when we were solving those equations, we knew all those properties, right? We have the distributive property. We had all the addition, subtraction, multiplication, division, properties of equality, substitution, transitive property. Remember all those from algebra? Block some of them out, maybe. That's okay. We have all those tools. We also have a tool called the linear pair conjecture. Okay, that's a geometric tool that we can use. So, anytime, just keep that in the back of your mind. Anytime we start a proof, we always start with what's given to us. Okay, so what's given to us are vertical angles 1 and 3. So I literally just have to rewrite that. And the reason I can say that is because that was the given information. That's what was given to me to start with. So now let's think about our geometric tools. The only geometric tool we have right now are linear pairs. So do we have any linear pairs in this figure up here? Yep, give me one. 1 and 2. So I know that angle 1 plus angle 2 has to equal 180 degrees because of the linear pair conjecture. Right, that linear pair conjecture said that if two angles are a linear pair, then their sum is 180 degrees. Now, from here on out, I'm not going to write out the words linear pair. I'll write LP. I'll say linear pair, but I'm only going to write LP. You're welcome to do that too. Use it a lot. Okay, so linear pair conjecture says that angle 1 and 2 have to add up to be 180 degrees. Do we have any other linear pairs? 2 and 3. So I know that angle 2 plus angle 3 has to equal 180 degrees, again because of the linear pair conjecture. All right, let's think back to your algebra days for a second. Think about when you had something like this. How would you solve that system? What do you think?
Probably if you see y by itself, just plug y into the equation and solve it.
Good. Set them equal to each other, right? This is one of your favorite ones. What was that called when you put in one thing for something else? Substitution. Okay, so keep that in the back of your head here. Notice that we actually have two equations. They both equal 180 degrees. So instead of a y, like we just saw, it's equal to 180 equals 180. So if they both equal 180, that means they have to equal each other. right? So that means that angle 1 plus angle 2 has to equal angle 2 plus angle 3. And we just said that that's a substitution. Right, so now we're really close to where we want to be for our proof statement. So look at our proof statement. It says angle 1 on the left and angle 3 on the right. I've got angle 1 on the left, I've got angle 3 on the right. The problem is I have an angle 2 on both sides. So what mathematically could I do to remove angle 2 from both sides? Subtract it away. What allows me to subtract the same thing from both sides of an equation? The subtraction property of equality. So now I can say angle 1 is congruent to angle 3 because of the subtraction property of equality. So we've proven for all vertical angles now that we can just automatically say the opposite angle or the vertical angles are congruent because of we've already proven it. It's called the vertical angle conjecture or the vertical angle theorem, if you want to call it that. We never have to go through this process again for the vertical angles. It's kind of like, you buy like, let's say we're building a grandfather clock. Okay, we have to buy a drill. We need a drill to put it together. So you get the drill out of the box, you read the instruction manual like you should, right? Like a good tool owner, you read the instruction manual so you know what you're doing, but how everything works, right? You use your drill, you put it away. The next time you get out the drill, do you have to read the manual again? No, you've never get your grandfather clock built, right? So we never have to do this again because we've read our instruction manual. We understand how this tool works. So from here on out, we just say because of the vertical angle conjecture. Okay? So a lot of what we do in honors geometry, instead of me just telling you vertical angles are congruent, we figure out why those things happen. So we try to make those connections. Good? Okay. It's our first geometric proof. This is a big moment for everybody here. This is where you should lie if you can say yes. All right. Take a minute here with your table group. You work with your table group. I want you to solve for all the missing angles. I'm going to give you about 2 minutes. Would any group like more time? Okay, I'll wait. All right, up here. What other angle has to be 70? Okay, and then what are the other two? 110. How about down here? What has to be 60? The others have to be 120. What has to be 8? or well, 50 is age. So the other two have to be
130.
130. Is that okay?
Yes.
Okay. So your homework, I'm going to bring you two papers. One has the problems on it. The other is just like a blank answer sheet. I don't care if you use it to write your work on, but it'll make it easier tomorrow to check your answers. Like it'll make it faster, so you're not searching through your work list.
I'm like, I have to do something.
Okay, so once everybody has them, I'm going to explain two quick things to you. The paper with all the problems, the paper with all the problems, I was incompetent at the copy machine and I took the holes on the wrong side. Apologize about that, so flip it over and start at number 1. And then, also while I was at the copy machine, I copied the answer blank first. And then I was getting ready to copy this. And there were 2 pages, and I just thought 18 problems was way too much. So I only copied the first 12. So on the back side of the answer blank, you'll notice you have 13, 14, 15, 16, 17, and 18. I just chose not to copy those, so you won't have anything to put there. So you're not missing anything. I just decided to cut back on it last minute. And I didn't want to waste paper to copy it again. Does that make sense? Okay, so the rest of the time is yours. If you need help, let me know. I think you should be able to get it done. Like